You guys must have heard about the James Webb Space Telescope that clicked these images. But do you know how and what goes behind clicking these images? We will just uncover it shortly. By the way, this is the first ever image captured by James Webb. This dates back to year 2000 for when construction of the spacecraft started. And not joking, this is a huge spacecraft. Let me show you the images. After completion and tests of the spacecraft, it was launched in the 25th of December, 2021 from Europe's spaceport in France, Guyana. It was to orbit Earth from 1.5 million kilometers, or 1 million miles, also called second Lagrange or point L2. This is done to avoid unobstructed view, stable orbiting, and cooling efficiency. So here's the part you guys have been waiting for, how James Webb clicked those stunning images. The James Webb is a 3-mirror in astigmat telescope, meaning the first mirror collects light from whatever you want to see, like a distant star or a bird in the sky. It reflects this light to the second mirror. The second mirror takes that light and reflects it again, making sure it's straight and not all jumbled up. This mirror helps fix any blurriness or distortions in the image. Finally, the third mirror takes that now perfect light and sends it to your eye, so you can see the object clearly. It's like putting all the pieces of a puzzle together so you get a clear picture. But first let's understand the hardware. The 18 gold-coated beryllium mirror with area 25 meters square act as a bucket for collecting the light. The light then gets concentrated to a small secondary mirror and to another tertiary or third mirror. A fourth mirror exists which act as a image stabilization before hitting the camera sensor. Rest of T. Heat capturing and post-processing is done by the SIM module. The Webb can see from 0.6 microns to 28 microns, or from visible light to near infrared. Here's the thing, we all know that the universe is expanding. The stars and galaxies that were before near to us move far away from us in space. And when something moves far away in the space, the visible light stretches out and gets red shifted. Looking into infrared is super important to us, as it will help study further into the past of the universe, understanding the early universe and galaxies. Webb is uniquely designed to observe these ancient and distant objects, equipped with an IR cam which can peer through the dust and a MIRI cam which can capture the infrared light emitted from the dust. The responsibility of translating Webb's observations into jaw-dropping images for NASA largely rests on the shoulders of just two people: Science Visuals developer Alyssa Pagan and senior data imaging developer Joseph DePasquale at the Space Telescope Science Institute in Baltimore. Pagan described both Webb and Hubble as akin to giant eyes built to take in massive amounts of light using mirrors. The images are published by false coloring, and for research purposes the images are evaluated raw, using the different spectrums for light captured by Webb. That's it for this video. I know the video is short. Sorry guys, been traveling a lot these days. Thank you, see you guys in the next one.